Okay, so this is unit 4, lesson number 5, the second part. We're going to look at two more examples. So here we have of solving quadratic equations. Okay, so here we have the shape of the Humber River pedestrian bridge in Toronto can be modeled by the following equation: y equals negative 0.0044x squared plus 21.3. All measurements are in meters. Determine the length of the bridge and the maximum height above the ground to the nearest tenth of the meter. So what points do I need to find the length of the bridge? Well, it'd be useful to have the starting point and where the bridge ends. Okay. Now, if you imagine a bridge, and this is on a grid, we can treat the bottom of the bridge as our x-axis, and so the x-intercepts become those 2 points, right? Okay. So we are going to find the x-intercepts. So this part here, x-intercepts. Okay. Now we need the maximum height above the ground. So whenever we deal with maximums, we are also looking for the vertex. Okay. So let's start looking for some x values. Okay. So I'm going to talk about the equations. The equation is slightly different than what maybe you're used to seeing. So if I write out the equation, we have y equals negative 0.0044 x squared plus 21.3. And when we're talking about the quadratic formula, we need an a, b, and c value. Well, a is right here. It's this number in front of x squared. C is that term that's by itself. Okay, so the 21.3 is not b, it's going to be c. B comes from the x term, but there is no x term in this equation. So we're going to say b is equal to 0. There's no x term. There's no b, but b is going to be 0. Right? Okay, so let's find our x-intercepts. Now we're going to find our x-intercepts. We need to make y 0. So y equals 0. So negative 0.0044 x squared plus 21.3. So here's the equation we're going to solve. We're going to use the quadratic formula to help us do it. And so here we go. So x equals, b is 0, so negative 0 plus or minus the square root of 0 squared, so 0 squared minus 4 times a, which is negative 0.0044, times c, which is 21.3. Extend your square root. Everything's divided by 2a, so 2 times negative 0.0044. Make sure you put that negative number in brackets. You don't want to confuse anyone because they might read it as 2 minus 0.0044. It's 2 times negative 0.0044. Okay, you simplify all of this, you're going to get x equal to plus or minus the entire square root becomes 0.37488, and square root divided by negative 0.0088, which will give us two answers. Okay, one plus, one minus. So here, two answers. So x could be plus the square root of 0.37488 divided by negative 0.0088, or it could be x equals minus, or negative, the square root of 0.37488 over negative 0.0088. And we get the two answers. One of them will be negative 69.58 and positive 69.58. Okay, so we're going to draw the situation of our bridge. So if you go back here, this is what we're going to be doing. Draw like an axis. This would be like your x-axis. Okay, we found our x-intercepts here and here. We're going to have y-axis over here. Okay, so we have a negative number, negative 69.58, and we have a positive 69.58. Okay, now let's just draw this sketch away from the picture. So here we have, okay, x-intercept negative 69.58 and positive 69.58. Let's draw that a little bit, make that a little bit more even right there. Okay. Okay, so if it's negative 69.58 and positive 69.58, where's my vertex going to be? The axis of symmetry is going to be right here on the y-axis. This is also my axis of symmetry, because it's 0 is the halfway point between negative 69 and positive 69. So that means my y-intercept, in this problem, the y-intercept and the vertex are the same point. So y-intercept and vertex, same point in this problem. Okay. So what's my y-intercept? Well, if you look at the equation, the c value is my y-intercept, 21.3. Okay. So therefore, 21.3 is here. So therefore, the max height is 21.3 meters. Okay. What's the length of the bridge? The length is equal to 69.58 minus the other value, negative 69.58, which is equal to 139.16 meters. Okay, let's look at one more example. Example 4. Van dives off a 4-meter springboard. His height, h in meters above the surface of the water, is defined by the relation h equals negative d squared plus 3d plus 4, where d is his horizontal distance in meters from one end of the board. Determine the zeros. So again, zeros is another word for x-intercepts. Sketch a graph. For what values of the d is the relation valid, and what is Van's horizontal distance from the board when he enters the water, and what is Van's maximum height above the water. So let's start with part A. Find the zeros. So to find those x-intercepts, we have to factor. Or you can use the quadratic formula as well. So factor or quadratic formula. So you might find that quadratic formula is straightforward, but factoring could be faster. So if I look at factoring the equation, I'm going to factor out a -1 first. So h equals -1 comes out. And I'm going to have d squared minus 3d minus 4. So basically changing the signs by factoring out the -1. Okay, and now I have a simple trinomial, two numbers that multiply to give me -4 and add up to give you -3. Those two numbers are -4 and +1. So my factored form will be negative d minus 4 and d plus 1. So there's my factored form. Okay, so from the factored form, remember height is 0 for the x-intercept, so d here will be +4, and this one, for this factor, d will be -1. So those are my two x-intercepts. Let's sketch the graph now. So part B, sketch the graph. Here's a quick little sketch. All right, my x-intercepts are at -1 and here at +4. My y-intercept from the standard form equation in the question is +4. So here on my y-axis, I'm going to put a +4. And this is the x-axis. And I'll sketch a graph like this. All right, there we go. So again, how do I know the parabola opens down? So from the equation, the standard form given to us in the beginning of the problem without the factoring. This one here, the negative sign is indicating that it opens down. Negative value of a. Okay, and the +4 again indicates the y-intercept. So these are the things you have to remember. Okay, part C. For what values of d is the relation valid? Okay, so if you look at part C, the relation is valid from 0 to 4 since the distance and height cannot be negative. Okay, so we're not gonna use this part. No, we're not gonna be using negative distance. We're using positive distance. So d is valid from 0 to 4 since distance and height cannot be negative. Okay, so let's move on to part D. What is Van's horizontal distance from the board when he enters the water? Okay, one more thing just about why is this not negative? Because remember, your springboard. He's diving off a springboard. The springboard is not on the ground; it's up in the air. So if that's his initial height, he's diving off a springboard from that height. He's not diving backwards; he's diving forwards. Okay, so he's going forwards. Okay, so part D. What is Van's horizontal distance from the board when he enters the water? So let's see. When he enters the water, So he enters the water. What is his height when he enters the water? So h equals 0. So that means at h equals 0, we're looking for the x-intercept, and we already found that x-intercept. It's here at 4. So he enters the water here at 4 meters from the diving board. So this is when he is 4 meters from the diving board. Okay, and then part E, what is that maximum height above the water? So maximum height means we need the vertex. Okay, so max height equals vertex. Okay, and so the vertex in this case is not an x and y, it's going to be d for the x, h for the y, so d comma h. So what's my d value? It's going to be the axis of symmetry. Okay, so I have to average my x-intercepts or my d-intercepts. So that axis of symmetry is going to be the 4 plus the -1 divided by 2. So you're averaging those x-intercepts, and that would be 3 over 2. Okay, or you could say 1.5. And we're going to sub that 1.5 into the equation to find h. Okay, so here's my equation. H equals negative d squared, so 1.5 squared, plus 3 times d, so 3 times 1.5, plus 4, and so the first term becomes negative 2.25, so 1.5 squared times 1. So 1.5 plus 1.5, then the negative in front makes negative 2.25. 3 times 1.5 is 4.5, then you're plus 4 at the end. When you add all those 3 terms together, you get 6.25 meters, which is his maximum height. So therefore, his max height is 6.25 meters. Okay, and that is it. That ends this video. Okay, now I make videos quickly. If you find that pacing was too fast, you can always change the video speed settings to make it a little bit slower and go at a slower pace. Or review the video again. All right, and so that's it. That ends this lesson.